Hello, mentors. Let's look at part 4, a mutation from our algas activity. Let's just recap. We have this alga pattern starting with a notice and wonder, as we saw in the overview video. Then we do a little exploration in the table in which we notice that the yellow just don't grow, just one all the time. The red grow by 2, as you can see here. And the total also grow by 2. And the accumulated grows bigger, much stronger, not just linearly. It actually grows as a perfect square. So 1, 4, 9, 16, 25, 36. Now the question was number 3. Number 2. If the alga needs 1,000 red cells or maybe more for level 100, will it be able to do that? What will happen? And of course, it doesn't really happen. At level 100, you only get 200 cells. So the next thing is a mutation. So we want to tweak the rules. Still start with 1 cell. Each yellow still generate 3 cells, and each red still generate 1 cell, but maybe being able to produce more red. So students will be able to try and contrast all the solutions to see if they can get more red at level 100 or in general. The first thing you could try is just to have all red as your base case and your generating rules, everything red, which kind of makes sense because after all, you're only interested in red. But what turns out, if you do the alga, if you just simulate this, is that you start with 1 and you don't really have yellow. So you're never going to be in a position to generate 3 red cells. So it's just going to look not too powerful, just 1 red every time. So we just see that this is not really a good way to do it, but it's worth the try. What if we try doing this? Start with a yellow, generate 2 red and a yellow from a yellow, essentially the same as here. But then in a very counterintuitive move, instead of doing red, red, we actually tell red to produce a yellow. And the intuition behind this would be that since yellow actually produced 2 reds, then we really want a lot of yellow. Let's see what would happen with this one. So level 0, you would start with this yellow here. So let's put it here. Then the generating rule would tell us that at the next level, level 1, since we only have this yellow, we would just produce these 3 cells. Then the red cells produce yellow cells. So we would be like this. And again, this yellow would produce these 3 cells. A red, and a yellow. And it goes on. So it gets really powerful because, as you will see, you're getting way more yellow, which you're not interested in the first place, but this yellow gives you the red. So that's kind of the beauty of it. Hopefully you understand this pattern. The red gets yellow, and here it gets. Okay, that's nice. So just take a look at it, and let's fill the table to see what we get. So let's start again with this first level. What do we see here in the first level? Well, we see a yellow, nothing else. Level 1, we see 1 yellow, 2 reds for a total of 3 and accumulate 4. Level 2, we see 3 yellow, 2 red for a total of 5, accumulated of 9. And in level 3, we see 5 yellow, 6 red, and a total of 11, right? For an accumulated of 20. Now we could do this, and we should do this without the picture or without, the manipulatives, without these round tokens that you guys will get. Yellow, of course, and red. But how do we get yellow in these generating rules? So look, no matter if you're a yellow or a red cell, you're going to produce 1 yellow token. So if you look at this total here, this 11, that's going to get you the yellow. So we see a very nice pattern here. 11, 11. And then how do you get red? You only get red from the previous yellow, from the previous level, but you get it in a duplicate way, right? So you get twice as much. So these 5 here really gives you a 10. That's kind of how it goes. So that's the pattern right here. It's a very nice pattern. Of course, 21 here. And of course, here, if you do the accumulated version, you'll get 41, right? And then we produce the same pattern. So this 21 here will actually be here. And this 11 here that I'm putting here will actually turn into not 11, but 22, because you duplicate the yellow, right? What happens is you end up really, really strong. So I won't get into much details, but let's just compute this next level. You would get a total of 43. And then adding up, you would get 84 cells. So the question, of course, is how is red growing? And so it started with 0, then 2 again, then 6. And now it's growing more. So it's just looking at the yellow pattern and duplicating. So you get now 10, now you get 22. Of course, in the next level, well, you'll get 42. So it just grows way more. And the question is, did you get more red cells than the previous alga? Of course you did. Which patterns can you see? So we already explained some of these patterns. And that's the activity right there for 4. Now, part 5, it's similar, just a little more complicated, more interesting. You get to tweak the rules more, so more freedom, and you get more power, because here you only were having a base and kind of 5 cells to choose from. So it's like if you had 5 choices to make. Whereas in this new mutation, which is the pattern ultra, you actually get 6 tokens to spend, so to speak, and you could distribute them almost freely. The only restriction is that you get maximum 2 for the red. So just to look at an example, you could just say, I'm gonna start with a yellow. I'm sorry, this is green, but should be yellow. And then get 2 reds. And then you could say, okay, my yellow is gonna generate a red and a yellow here, and my red is just gonna generate a red. Let's just check. We have 1, 2, 3, 4, 5, 6 tokens to fill out these green spaces here. So that's totally fine. And there's many more chances. It's an optimization problem. We want to maximize the number of reds. But of course, we see that it's just not enough to just concentrate on red. You gotta give way to yellow, because yellow can have more babies than the red, because the restriction here is that the red cells can have at most 2 cell babies, so no more than 2. Then you would compare these alga that you make from the ones, from your partners or other students or mentors, which seems to be the best in terms of the number of red cells produced. Overall, accumulated or at level 100. So there's many ways to look at, maybe just level 8 to start with. And then how do you know? How do you know these patterns? How do you know how they're growing? So you get into a complicated discussion into growing patterns. Of course, it's no longer linear. We saw this even in the first pattern, the accumulated is not linear. But here, these patterns here for yellow and red are clearly not linear. You're not just adding a constant number. That's just not the case. You're growing, bigger and bigger. And, you just explore those patterns. So hope you have a lot of fun in this activity. And just compare a lot. So everything that a student produces compared to the other students. Students can also change the patterns just to tweak them. Think they're designing a car or some complicated system, and they can test it out, but they can go back to the drawing board and make changes. Also, make sure you use these tokens, which are here in detail in the teaching manual, the red and yellow tokens, to represent how the alga are growing. Okay, have fun.